Good afternoon, and I think I'm following on two good presentations here, and I think I'll take you back to the design phase and the planning phase of the projects. We are looking at, sensor-based data acquisition. Now we are in this presentation. I would like you to take back to the planning phase, where we will look at some of the issues associated with data again, but most likely the modeling data and how that affects the automated compliance checking. This is predominantly my student's work. He's a PhD student, Ankan. He's in Singapore now and couldn't make it to the conference, so I'm presenting on his behalf. Let me quickly go through it. So we'll talk a little bit on how automated compliance really works, and what is that we are trying to look at in this study, especially what sort of things we are looking at the data and how are we enriching it. So just to give you a brief idea, I'm not going through the slide entirely, but I think the automated compliance checking finds a key role in our country, at least, because I think the most problematic area for us is to get permits for construction. In fact, many projects in the country are stuck for at least 1 or 2 years, getting different kinds of permits, like your fire clearances, the environmental clearances, etc. So that is where the automated compliance check kind of comes into picture, where we would like to reduce the number of iterations in terms of code compliance, and also make the process a little bit more transparent than what it is right now. So that's where we started off working in this, and thanks to funding from a company called Softtech, which is also developing these areas and is in tie-up with many of the urban local bodies in the country. We tried to understand how to do it, and the theory is all there, so we thought, yes, let's go and do it. And then we found out that the proverbial devil is in the details, right? I mean, as we started off with this entire thing, we saw that the modern tools are essentially the BIM tools. What you see, they are focused on the modeling aspects of it and the construction sometimes, but in terms of code compliance, you have a lot of gaps in terms of what the tools can achieve, and therefore predominantly, and this is part of some of the references which actually also speak about the same thing, where predominantly, not only in our country but across the world, you see that these permits are manual, time consuming, and restricted to very simple of the cases where you have simple numerical checks, like less than, greater than, equal to checks. So that's where we thought we'll have to look at the data which is used, and what we found out, and we are building on Bloch et al. 2019 paper here. So we saw that data, for example, when you come to BIM, you have explicit data, which is quite nice for a rule checking kind of thing, but then you have a lot of implicit or missing data, and that's where the rule checking or the compliance checking becomes a little bit more complex than what we thought of, right? So usually you have this design data, which is essentially your specifications, your codes, etc., which will aid you in decision making. Then you have some kind of explicit data. Just to give you an example, like width of a wall or the geometric placement of a wall. So those kinds of data are readily available in your models, but the major problem is this missing data, and that's where I think, as earlier researchers have come up with, we have to look at some form of augmenting of this implicit or missing data in order to make our models compliant for automatic code checking. So this we took the path of semantic enrichment of our BIM models in order to make them, the automatic code ready, code compliance check ready kind of phenomena. So essentially what we are seeing is we are looking at a BIM with an IFC based information format for exchange, but what we see is that there's a lot of explicit data, but then this implicit data becomes much more difficult to handle, and that's where we are trying to understand. Sometimes we will talk about these relationships, so we'll just talk about the topology of definition of IFC in order to understand the problem with this. I'll also then we'll look at one way in which we handled this problem in our study. So for example, if I look at a general IFC structure, which most of you would be familiar with, you usually have the geometric information in the nodes. Usually you have your physical topology, which is essentially the spaces and the geometries of different kinds of elements in the, in your model. But then you have these very important associative topologies like what we heard in the graph neural networks earlier as well. So you see that these associative topologies become very, very important for code compliance checking, right? I mean, though this physical topology is very crucial as well, this is the area where we found out that we have a huge problem. Because if you look at the IFC structure now, IFC window, for example, is right under building story, right? And usually your roof or wall has an opening element and your window has an inverse relationship with that. So you have to kind of dig this up and then start associating a window with a wall, right? So you have a lot of these kinds of involved convoluted kind of relationships within the IFC. 1 minute, 2 minutes? 2 minutes, right? Yeah, that's good. So that's what we will be looking at. So if you look at some of these things, for example, here IFC has a window element, but it can, you have a skylight predefined type, but usual modelers, they actually define it as a window. When you export it, it will become a window. Now you do not know whether it is on a slab or a wall, right? Similarly, many of the walls, they have is external, but usually from many of the tools when you export, internal and external walls become, yes, they all become external. So you have to have a logic behind tagging them back to internal and external, right? So let me just tell you what we are trying to do. We are looking at the semantic enrichment let me just go through this. So essentially, what we are looking at is there are, for any design process approval, you have a pre-processing task which will have a lot of semantic enrichment where your rule-based approaches or machine learning basis approach can be used. But for verification stage, what we found out was a fully rule-based approach is what is important because you need 100% accuracy in terms of verification, right? Let me quickly go through, I'll skip this slide for the want of time. Yeah, let me just give you this example why this kind of implicit to explicit data is important. For example, you have a sunshade here. The idea, but the problem is it's wrongly classified as an IFC slab, and this is the usual modeling thing which we do. But even if you have a shading device, it's a geometric placement. You cannot really associate that this sunshade is associated with window directly from the IFC. So how do I go about enriching this thing? So that's what we did in this kind of exercise where we said, okay, let's do what we do. First thing is, we had to classify this window as internal or external. Then what we did was we looked at creation of automatic boxes, bounding boxes, and then shifting it up so as to identify that this sunshade belongs to this. And if this slab element is at the level of the next roof, then it's essentially not a shading device, right? So essentially this is the automatic rule augmentation which we have done to the existing schema in order to do that. Then we have applied how do we find out the minimum width of it? Because the rule in the code says that the minimum width of a sunshade should be so much. That's the only rule which you get from the code. But in order for you to automatically check this is the kind of semantic enrichment. This is a rule-based enrichment which we have to do in order to come and become compliant with the code. So that's what you see. And then once you have done that semantic enrichment, then it becomes a very simple code case, where you say if this and this is this, then please pass, otherwise it's fail. So in order to get to this compliance kind of code, your model should be enriched, and that's the process which we are looking at. So, in order to conclude this entire thing, so there are two processing and verification stages, and I think semantic enrichment becomes very, very important in the pre-processing stage. And what we do is essentially, if you look at data, this semantic enrichment is very, very essential for generating the missing or implicit data for your verification. And Sometimes you might have to go beyond rule. Right now you saw a rule-based approach. We have extended this work further where we are now looking at machine learning-based approaches for certain very complex kind of implicit data. Like for example, I think I'll just conclude by saying that, what we went ahead and extended this is like, for example, if you have a room plan, for a floor like this, can I automatically tag it as a conference room, as a toilet, as a bedroom, or a room in a hotel, etc. So that kind of tagging is not available in BIM, and it's much more complex than what we saw for a sunshade identification here. For such kind of complex tasks, machine learning is important, and we have developed 2 or 3 methodologies in machine learning to tackle those problems. So from a framework perspective, there is a trade-off when you can switch from a rule-based to a machine learning-based approach. So that's more or less what we are looking at in this compliance check. Okay, thank you.